Hi everyone. A particle moves along the x-axis so that its acceleration at any time t greater than 0, or t is positive, is given by the acceleration of t equals 12t minus 18. So what we have to do, we have at time t equals 1, the velocity of the particle is v of 1 equals 0, and the position is x of 1 equals 9. And we have to answer these 4 questions, write an expression for the velocity, and at what values of t does a particle change direction, write an expression for the position, x of t of the particle, and find the total distance traveled by the particle from t equals 3 over t to t equals 6. So let's start with the first part. We have to write the expression for the velocity of the particle v of t. So when we do that, we know that we have that the derivative of the velocity with respect to time is acceleration. So the integral of acceleration equals your velocity of t. So we kind of have to work backwards because they gave us acceleration, and so that's why we have to integrate. So let's write our problem here with respect to time, and then do the integral. So antiderivative, basically. So what you're going to get is 12t squared over 2 minus 18t plus c, which is equal to 6t squared minus 18t plus c. Now, if we have to find c to finish this up, if we plug in information at t equals 1, then the velocity of 1 equals 0. So we can solve for t. So we're going to plug in 1 and set it to 0. So 6 times 1 squared minus 18 times 1 plus c equals 0. So this is going to be 6 minus 18, which is negative 12, plus c equals 0. So c equals 12. Therefore, the velocity of the particle, which was this one, is going to be velocity of the particle equals 6t squared minus 18t. Now plug in your c plus 12. All right? Now we have to find what values of t does the particle change directions. So basically, we're just going to set up our 6t, our velocity, 6t squared minus 18t plus 12 equals 0. I'm going to divide everything by 6 here, and just 6, 6, 6, 6, 6. So we get t squared minus 3t plus t equals 0, because this would be our first velocity at t. All right, so you factor this. We get t equals 1 and 2. So this is the values of t where the particle changes directions. We're going to come back to this in a few moments. Now we have to write an expression for x of t of the particle. We know that the x of t is your kind of original type function. So we know that that is the derivative of the position with respect to time is velocity. So the integral of the velocity with respect to time is its position. So basically we have this, and this is your position. So basically we're going to take the integral of our velocity of t, which is 6t squared minus 18t plus 12 with respect to time. and integrate that. And you're going to get 2t cubed minus 9t squared plus 12t plus c. And that's going to be your position vector, or your position of the particle. So now that we have that, we're going to have to do the same thing and find c. So we know at time equals 1 that our x of 1 equals 9. That was given in the problem. So all we're going to do is take our equation, plug in our 1, and set it to equal 9. So this is going to be 9, and we're going to plug in 1s in here. So you get t times 1 cubed minus 9 times 1 squared plus 12 times 1 plus c equals your 9. Now solving for that, you're going to get 5 plus c equals 9. So c equals 4. Therefore, the position of t equals 2t cubed minus 9t squared plus 12t plus 4, your c here. All right. Now to find the total distance, we have to find the total distance where from t equals 3/2 to t equals 6. Now normally all we have to do to find the distance is to integrate the velocity equation from the starting point to the ending time. But we have to watch out for where the particle changes directions. If so, we have to break the integration into two parts. A positive one when it's traveling to the right, and a negative integral when it's traveling to the left. And we already know from earlier that the particle changes directions. So it changes directions earlier at t equal 1 and t equal 2. So we need to know which direction the particle is moving at time 3/2, and we can do that by plugging 3/2 into the velocity. So the velocity, and looking at its sign, so the velocity again was 6x squared minus 18x plus 12. All right, so let's plug in our 3/2, so we get 6 times 3/2 squared minus 18 times 3/2 plus 12. When you evaluate that, you get negative 3/2. Okay, and the next thing we have to do is evaluate at 6. So we know that this is negative. Since this is negative, we know that the particle is moving to the left from t equals 3/2 to t equals, what did I do that for? So t equals 2. It's moving left because it's negative. All right? And because we know that the particle changes directions at t equals 2, it must be moving to the right after that. Therefore, we're going to need two integrals, one for t equals 3/2 and one for t equals 2. So this is, and then we also need one for t equals 2 to t equals 6. Let me just write that. So we need an integral for t equals 3/2 to t equals 2. And we also need one for t equals 2 to t equals 6. So basically we set up our integral, and we're going to have 3/2 to 2, and that's going to be to the left, so that's negative 6t squared minus 18t plus 12, derivative of t, Okay, and then plus the other integral, and that's going to be from 2 to 6. And that's going to be, this is to the right, 6t squared minus 18t plus 12, the derivative of t. So basically, we've already integrated this part right here in part C that we did. So now, when we integrated it, we got 2t cubed minus 9t squared plus 12t plus c. But now, instead of solving for the constant, we evaluate the equation at the limits of the integration. So this is what we have, and we're going to evaluate it at the limits of the integration. So basically what you're going to have is negative 2 times 2 cubed minus 9 times 2 squared plus 12 times 2. So that's the first part. Plus, then you have 2 times 3 halves cubed minus 9 times 3 divided by 2 squared plus 12 times 3 over 2. And there's that. Then we have to add the second part, the second integral. So the second integral is going to be 2 times 6 cubed minus 9 times 6 squared plus 12 times 6 minus, and then we do the other portion, 2 times 2 cubed minus 9 times 2 squared minus 12 times 2. All right? So basically, what we're doing is doing this. Basically, this is our problem. 2t cubed minus 9t squared plus 12t, and we evaluated it from 3 halves to 2 from this first part, and then we added this one, 2t cubed minus 9t squared plus 12t. We evaluated it from 2 to 6, and we already did that part, so this is those two parts right in here. Now, so your answer is going to end up being negative 4 plus 4.5 plus 180 minus 4. And this gives you 175.5, or if you put in fraction form, this would be 353 divided by 2. And that's all. Thank you. Have a nice day. Bye-bye.